Good afternoon, good evening, depending where you're dialing in from. My name's Tom Cornell, and I'm a senior IO psychology consultant at HireVue. And so for the next 45 minutes or so, I'm going to talk you through what this not so catchy title on screen is actually referring to. So yeah, the development and implementation of transformative open source approach to bias mitigation within an assessment and selection context. So in a nutshell, I'm going to walk you through I guess a little bit about how we approach assessments at HireVue. With our AI scored interviews, we do things a little bit differently. That then leads quite nicely into why, I mentioned the word AI, you kind of have to talk about bias, why bias mitigation is so important and the approach that we developed, and then kind of some of the results and the outcomes that we've seen as a result of that. As Stuart alluded to, we kind of submitted this for last year's awards, and we won the award for the D&I in the private sector. So doing what we can to make the world of AI a far less biased place. I'm not going to turn this into a sales pitch, but it's certainly useful to get a bit of context around HireVue, particularly our assessment technology. So in a nutshell, we are a technology platform. We have a number of different technology-enabled solutions that help our customers engage with the best candidates faster than their competitors. Really, at the core of this is our structured interviewing platform, so delivering asynchronous or live interviewing through a purpose-built platform. We have things like scheduling capabilities, so successful candidates through an integration into calendars, candidates self-select when they want to come in for their second stage interview or book in their assessment center, whatever that may be. Conversational AI and text automation, so we have a conversational chatbot that can sit on the careers page, help qualify candidates, direct them where they need to be, text and WhatsApp reminders, invitations, so on and so forth. But then the most relevant, most important of all these for the conversation today is our assessment capabilities. So through this singular platform, we can deliver more traditional methodologies, things like SJTs, personality questionnaires, work sample tests. We then have game-based assessments, and then on, I guess, the most relevant side are AI-scored interviewing. And it's the AI-scored interviewing that I guess really sets the scene for the conversation today. So when we talk about AI-scored interviewing, what we're essentially doing is we are taking an asynchronous interview. So we're not scoring a live interview in real time. We're scoring asynchronous responses to predetermined questions, and applying some form of scoring model in the back end to automate the scoring of that candidate's response. We're focusing on behavioral questions, so typically past behavior, describe a time you did X, or situational, imagine you're asked to do Y, what do you do? I'm sure we're very familiar with those. And then the first step is a speech-to-text transcription. So we use a company called RevAI, who can outstrip the likes of Google and Amazon, particularly with things like different accents or different ethnicities. So we're transcribing that audio into text, and then it is the text that is analyzed by our NLP, our natural language processing and scoring models. You can have the video turned on, you can have it turned off, the AI doesn't care. If it doesn't come out the candidate's mouth and can't be transcribed as a word in the Oxford English Dictionary, then it's not going to be scored by the AI. The video is just there for the recruiter's benefit if they and the candidate choose to have it there. So that seems very easy. Just transcribe it and score it, right? So obviously we're going to break that down a little bit and understand, okay, well, how actually can we and how are we scoring interviews utilizing AI? I think the best place to start on that is by considering how they're built. So this is the approach that we take, and of course there are other ways that other companies have chosen to tackle this. But we kind of start with gathering that data. So we've gone into our database and we've extracted around 2,000 responses from real candidates for each of the competencies in our library. So we have 19 competencies we can assess, things like relationship building, problem solving, teamwork. We're extracting around 2,000 responses for each of those competencies. And of course, we do what we can to sample it. So it's not all coming from one company in the US, where you can balance it based on the geography, the demographic data, etc. So we can try and get a good representative sample. We then onboard a team of behavioral analysts. So we've run this process 3 times from our kind of initial build up to iterating on top of those. And across those 3 rounds, we had a total of 37 different people involved. So again, this isn't just, a bunch of white males in suits evaluating interviews. It's designed to be a large, diverse group of individuals who then actually go around the process of evaluating these responses. We give them some training, cognitive bias awareness training. We teach them best practice around evaluating interviews. We give them behaviorally anchored rating scales, so 1 to 5 scales with behavioral indicators for each competency we're assessing. And they then start this fairly arduous process of evaluating these thousands of interviews. So each interview or response is evaluated by at least 2 people. In many cases, 3. Again, just trying to kind of balance out any individual biases or interpretation that any one individual might have. And that's then what gives you your kind of labeled data, right? You then got 2,000 problem-solving responses. Here's a 1 out of 5 response. Here's a 2 out of 5. Here's a 3 out of 5, so on. And you essentially give it to the AI and say, right, learn to replicate why some got scored 1 out of 5, why some got 2 out of 5, some got scored 3 out of 5. So that kind of makes sense. There's still a bit of a gap there, still a bit of a jump. So like, what is it actually learning? How is it understanding these open-ended responses? So we are fortunate, or I guess my job nowadays is made a little bit easier because most people, I think, have an appreciation of what, I guess, kind of the ability of AI to understand human language. I think most people here have either directly played with or seen a video of someone playing with something like ChatGPT or some other Gen AI model. And now people kind of get that AI has a pretty good way of understanding and replicating the English language. People are no longer thinking, oh, it's just keywords or individual phrases that if I say enough times, I'm going to get a good score. It's kind of gone well beyond that point. And that's kind of what we've leveraged here as part of that. We are leveraging large language models in a similar way to what OpenAI have done with ChatGPT. We're just taking a base of a large language model that has a very in-depth understanding of the human English language. In this case, we use Facebook's Roberta. Roberta is an acronym. The full thing is very long and horrible, so I'm not going to give it to you here and now. But the key part of it is actually the B in Roberta, which stands for bidirectional. And this is what made BERT, the kind of first generation of it, so impactful, was because it really could better replicate how we as humans formulate and understand language. Even though we might write left to right or right to left, and so you read kind of, you might think you're reading one word at a time, or when you're listening to what someone's saying, you're consciously hearing one word after another. Actually, what kind of someone says primes what you expect to hear in terms of what follows. And equally, you're updating what someone has just said based on what follows. Like, you might consciously do it, but you're changing your understanding of it. We are essentially understanding language in a bidirectional manner. A really good way to conceptualize this is if you're on a Zoom call. I mean, it may have happened to any of you already on this call. If someone drops out for a second, or you take your headphones out to see if was that the dog barking, and you put it back in, you don't have to kind of throw up your hand and say, "Oh, that's it. I've now lost the train of thought. I can't understand what's going on anymore. This is pointless." You know, as a human, from what came before and after that 2, 3, 4, 5 word gap, what probably filled that space. You might not know the exact specific words that I used or that person used, but you'll be able to give a pretty good guess, or at least be a very accurate homonym. Say, oh, okay, actually, they kind of said this instead. So we can base that based on what we heard before and after that blank. And that's essentially how Roberta learned to understand the English language. It learned by masking words and phrases in a large body of text and kind of understanding how well can I predict the missing word or words. If you predicted it well, great, thumbs up. If you got it wrong, you had more learning to do to understand why that was going on. So that's kind of the base point, the base starting point. One of these large language models that, as I said, has a very good way of, a very human, dare I say, way of understanding or learning language by considering that bidirectionality, that we don't, as humans, approach the language one word at a time and single words in total isolation. So in order for AI to replicate that, it also had to adopt and understand that approach. So that's the starting point, but still doesn't explain how on earth we have these AI scored interviews. But that gave us the first step. Step number one here is Roberta. So it's this large language model, open source, was trained on 30 billion words. If you read the body of text that Roberta was trained on at the average speed a human reads, it would take you about 200 years without breaks, without pauses, without sleeping. So Roberta has probably been exposed to more words than about a couple of dozen people will in their entire lifetimes. That's the volume of text that it was fed to say, right, understand how this all works, understand the different words we use, which words appear in what order, why certain phrases are different to other phrases, just understand the English language. We then took that and fine-tuned it to an interview context. We all know that job interviews are not real life. They're not really very representative of how people generally speak. If you were, at the pub with your friends and someone said, "Hey, how's your day?" and you then, talk about your experience in a very self-inflationary process and use the STAR technique, they'd probably look at you like you're really strange. Like, people don't talk in interviews and use words and phrases in the same context as they do in general life. So we took Roberta and kind of fine-tuned it on 1.5 million interviews just to say, hey, look, this is actually how people talk in our context. We then further fine-tuned it another step based upon communication ratings. So as I alluded to, we have around 19 competencies in our library. Each one had about 2,000 responses being evaluated. But as these analysts were evaluating the response based on the target capability, so it's a problem-solving response, that's a 2 out of 5 for problem-solving, they also scored it 1 to 5 for communication based on a separate communication rating scale. So that kind of massive communication labeling is what we could then use to say, hey, you understand the English language, you understand it in an interview context, now understand when it's used well in an interview context, i.e. articulated in a clear and coherent manner, and understand when it's used badly in an interview context. Then that very final layer, step number 4, is when we then trained it, right, now understand a bad problem-solving response and a good problem-solving response, that kind of final layer that goes in there. And that's the steps we kind of go through, the training layers that our NLP models went through to then say, right, you now understand the English language, communication, and behavioral indicators of different capabilities in order to then actually score future candidates. Custard is what our final model is called. Roberta is an acronym. Our initial model was called CAKE. Isn't an acronym, but it's because CAKE has lots of layers, as do these models. And then Custard is our most recent one because Custard is the layer that sits on top of CAKE. Our data scientists are brilliant with numbers, but they really think they're comedians as well. So that hopefully sets a bit of the context around the type of, I guess, data or the type of thing that we're working with, why the approach we're going to talk about is so important. Because we're leveraging huge data sets. The approaches we're looking at here, and not just specifically here, it could be any other situation where algorithms are being used to predict should mortgages be used, mortgage loans be approved based on all these different sources of data. Some of your more traditional approaches to mitigating bias perhaps go out the window. You're not dealing with 50 multiple choice questions with a +1, -1 scoring key. You're dealing with essentially every word in the English language, which can be combined in all these different ways. All of those could be features in the model that gets a positive or negative score when used by a candidate based on what the model has learned. So your number of predictors essentially becomes potentially in the millions. So that's when you have to start looking at other ways to understand the model and think about how you approach it from a bias perspective. So without further ado, that brings us nicely.
There's an interesting question in the chat you may want to look at. I don't know if you want questions at the end or now, but Peter,
no, that's a good natural pause. I'm happy to dive.
Yeah, I thought Peter, you can unmute yourself and ask, or if yeah, why not?
Sure. I was just interested in the training data and whether there was anything about job performance in there? So rather than this is a good response and this is a bad response, is there anything about this response came from someone who later proved to be highly effective in the role or relating to this competency?
No, not at this stage. So the initial stage was essentially that kind of the kind of that construct validation perspective, right? Because of course, when we're extracting these from the database, we didn't necessarily then we necessarily didn't want to have to locate each company and say, hey, we've used John's data. How's John worked out? Is he good or not? From the perspective of replicating an interview evaluation, it almost doesn't matter if the person went on to be a top performer or not, because if they gave a 5 out of 5 response in the interview, they gave a 5 out of 5 response, regardless of whether they actually then turned up and they weren't kind of right for the job. So no, in building the models, it's based on the data that the model has access to, which is what they did in the interview. Okay. So with that in mind, as I said, big data, lots of features, lots of predictors. And so we are then, of course, delving into the roles of algorithms and AI. And of course, you can't talk about algorithms and AI without saying the word bias within pretty much the same breath. And look, I'm not being flippant about this, but it is important. Our dear friends at Amazon, probably set back the industry multiple years. I mean, it's been 6 years now, but it still seems to be the story that everyone likes to pull out when talking about the risks of AI. But I'm sure we're all quite familiar with. Amazon essentially tried to build a tool that can analyze candidate CVs and essentially make predictions about that individual's likelihood of success in the job. They're certainly not the only ones, but I think they're doing all right, so people don't mind dragging their name through the mud, perhaps. And kind of fundamentally, it is quite a fitting case study because it highlights, I guess, one of the, or possibly the major issue, the biggest challenge with training AI-based models is your model can only really ever be as good as your data. If, in the case of Amazon, you had a bunch of CVs, some belong to men, some belong to women, and just by coincidence from the CVs that you fed into the tool, the male CVs were just stronger than the female CVs just by chance who you chose, then it's going to pick that up. It's going to say, well, male-based language tended to belong to better CVs in the training data. Therefore, in the real world data, if it's a male-based CV, I should add 10% to the score because that makes me more likely to be correct. That's kind of fundamentally where these things come from, right? But it's not the data scientist has a grudge against a particular group and therefore tweaks some code. Rather, it's the data that's presented to it. The human might not be able to understand what exists in it because we haven't got that level of understanding. But then as the AI is learning from it, understanding the patterns that exist within it, it then starts to kind of understand this. A great example I also like to use around this was that it wasn't that long ago where you were more likely to be, I think it's a FTSE 100 CEO if your name was John than if you were a woman. So if you just took the LinkedIn profiles of the top 100 CEOs and said, learn from this and make predictions about the future, you would probably find in that model would be a feature saying, if person's name equals John, then, as I say, add 10%. If person is woman, deduct 10%, because that is a fundamental bias that existed within that data. Another example I want to talk about, which is slightly on a tangent, but I get bored of the Amazon story. I think this one's not more interesting, but Airbnb had a really interesting case, and for a slightly different reason. So Airbnb realized that, I believe it was in the US, but essentially black Airbnb hosts were undervaluing their property when putting up an Airbnb. So when you put up an Airbnb, you can say, I want $100 a night. They realized that the black hosts were severely undervaluing their properties compared to white hosts, meaning that fundamentally they were earning less money through the platform. So what Airbnb did is they built this smart pricing feature. So they fed it a load of data, and basically if you clicked yes, smart price my home, whatever the wording was, it would look at all these different features based on the location to certain amenities, the size of the property, the price of other properties in the area, how many properties are there, all these different things would go in and it would say, right, you should be charging $120 a night. So do you want to charge this amount? And actually the model worked great. There wasn't an issue with the data. There wasn't an issue with the modeling. It actually increased the average earning for both black and also white hosts. Both groups clicked in, I want to use smart pricing feature, and they were getting more money per night for their properties. Unfortunately, the adoption of the feature had significant racial disparities. So black hosts were far less likely to opt into this feature that improved their property price versus the white hosts. And so as a result, it actually further increased that gap. So likely due to a lot of the stories like Amazon's, whereby probably women and minorities hear all these stories of, oh, hey, this AI-based tool was biased against us. When they said, hey, do you want to use this AI-based tool? Probably said, absolutely not. Like, I'm mistrustful of it. I don't want to use it. And so it kind of highlights why, this kind of, I guess, fight against bias, or why showing that we can do more about making AI less biased is so important. Because actually, poor Airbnb's case, what they did was exactly the right thing. It worked great. It had the intended effect. But just due to public perception of AI or algorithms and the risks of bias, the people who actually fundamentally was going to benefit didn't want to use it, and it caused an increase in that earnings gap. So we've already talked a lot about the big source, or one of the biggest sources of issues with algorithmic bias is that data. If there are irregularities or biases that exist within your data, it's very hard to get rid of it. So garbage in, garbage out. You can't out-train bad data. There's all these kind of sayings that we like to throw out. But this, of course, creates a problem for all of us who want to work with this data, because we know that a lot of this data, you can't just simply harvest in a lab. You say, right, this is exactly the sample size I need. I'm going to perfectly balance all these different things. I'm going to check it. I'm going to do corrections. You can't do that when you're dealing with real people's data, when it's a job interview, or whether it's social media profiles or whatever it may be. You aren't able to perfectly control all of this. You can take whatever steps you can to try and improve the quality. So instead of sampling correctly, running some bias mitigation in our circumstance, you can do what you can to improve the quality of that data, but it's always going to be that unknown, very human kind of variable, that very unknown human element. And so that is then what brings us to the bias mitigation process. So whereby you accept this data is not going to be perfect, but we don't have to put out an imperfect model. We can undertake steps or processes to try and strip out or reduce the effect of that bias that exists within our data before we then go actually and publish that model. And of course, it is a cyclical process. Once you publish a model or something is live, you don't then just sail off into the sunset. You monitor it, you gather more data, you can go through this process multiple times. But certainly before you're publishing it, you want to run some kind of bias testing, as we all are probably very well aware, but then also some form of mitigation to reduce the potential impacts of that. And that forms the very basis of our submission last year, and kind of the research that we're talking about today. Is we developed a new approach to mitigating bias, particularly within those big data circumstances. So here in an assessment selection context, but actually it can be applied to many different contexts outside of our space. And we contrasted it to essentially kind of the most commonly utilized approach at the time, still probably now. If you compared and contrasted our novel approach to I guess the most commonly used approach of the day, and looked at how the two contrasted to each other. So the probably most commonly used approach, which we compared it to, is a method called iterative predictor removal. And for those of you who aren't familiar with iterative predictor removal, fundamentally what you do is you iteratively remove your predictors. So as we talked about, if you've got an open-ended question, and essentially any word in the English language could be a predictor, and actually equally phrases can be predictors. So any 2, 3, 4, 5 word combination of English words could be predictors. You are talking, as I said, millions of potential predictors, i.e. millions of elements that could be positively or negatively weighted against a candidate's score. What you do in this approach is you would rank them essentially based on how biased they are. So whatever measure you're using to determine bias, let's say against male and female, you would rank all your predictors and say, right, the number one most biased predictor, most biased words or phrase is X. The second one is Y, third one is Z, so on and so forth. And you essentially would then just cut out a section of those. You would perhaps say, right, let's take the top 100 and get rid of them. We delete them from the model. They're really bad. They're contributing to bias. We don't even want them in the modeling approach. You redo your statistical and practical tests for adverse impact. Okay, that improve things, but it's still pretty bad, right? Let's get rid of another 100. Getting close, still not quite where we wanted to be, right? A third iteration, 100 more predictors go, fantastic. We're now comfortably within acceptable ranges. We're now happy with this model. And this approach is effective. If you do that for gender, you then do it again for ethnicity, you do it again for age and so on. And you're getting rid of really biased data from your model. And of course, it has a positive effect. But the downside is you are deleting data. You're removing predictors that could potentially be very useful. You don't know exactly perhaps what some of those predictors were. And so by removing them, you are potentially ignoring what's potentially a candidate could be saying that is actually very useful to understand their level of capability in a certain area. So the approach that we developed and utilize today is a method called multi-penalty optimization. With multi-penalty optimization, what you're doing is you're simultaneously penalizing all of your predictors as a proportion of how biased they are. So you're not just taking the top 100, 200, 300, whatever it is, worst offenders. You are essentially applying a cost function, so a negative weighting from number 1 all the way down to number 1 million. Now, it is proportional. So once you're getting to number 1 million, in fact, probably once you get over, a couple 100,000, that cost function is probably essentially 0, if not 0. But at the top end, you might be removing or de-weighting your top 100 predictors by 90%. So your next few hundred go down 80%, so on and so forth. So everything is affected as a function of how biased they are against your different groups of interest. Let me put that into a layman's perspective, a little analogy I quite like to use to describe this. Let's imagine you are dieting, you're trying to lose weight, or you're trying to maintain your current weight. There are 2 approaches that are suggested to you. Approach number 1, you basically keep a diary of what you eat in a week, and you note it down. So you say, right, for lunch every day, I go and I get a cheeseburger around the corner. On the way to the office, I love getting a triple caramel latte. And on weekends, every Sunday I have curry for lunch and dinner. And what you say, great, those 3 things are pretty bad. They're pretty high in calories. I'm just going to get rid of them. I'm going to stop eating them. I'm just going to do a crash course, just cut them out of my diet for as long as I can and see what effect that has. Now, of course, this is going to have an effect. It is going to be impactful if you cut this really bad stuff out of your diet. Unfortunately, number 4 on your list was that block of cheese you snack on the tube in the morning. Number 5 on the list was that 2-litre bottle of Coke you drink throughout the day. You're not paying any attention to that stuff. And so unfortunately, that is going to slightly inhibit the effectiveness of your dieting journey, because you're not paying attention to things that they're pretty bad. They just weren't quite bad enough to get into your kind of your hit list, so to speak. So on the other hand, the alternative approach you can take is what we would all understand to be everything in moderation. So everything you're eating, you just stop and consider, is this good for me, and how much of it should I therefore be eating? So you don't have to get rid of curry Sundays. You don't have to stop eating burgers altogether. Maybe just once or twice a week. That triple caramel latte is now just a single caramel latte. And then the things below it, that block of cheese, you're eating less cheese in the morning. It's a low-fat cheese. You're not drinking 2 litres of Coke. You drink 1 litre of Coke. Fruits and vegetables you barely need to think about, because actually you can eat as much celery as you like and you basically don't put any weight on. So you're considering everything at the same time as a function of how bad it is for you. And that fundamentally is the 2 approaches. It's a crash diet by cutting particular things out and ignoring the rest, and essentially moderation. And as it is with kind of that analogy, there are differing levels of effectiveness. And why these approaches become, so important, or how they work, we can consider kind of the context within that validity diversity dilemma. So, of course, validity diversity dilemma generally talks about from a perspective of things like cognitive ability tests, right? In a hiring process, some of the most valid predictors are unfortunately the most biased. And so when you're designing a hiring process, you have that trade-off. Well, do I include something like cognitive ability testing, which maximizes my likelihood of finding the strongest talent? But then as a result, I know I'm going to take a blow on the diversity side of things. Or do I not include it because I want to put more focus on diversity, but then I know that I might suffer my quality of hire? You end up with this kind of trade-off in the middle, right? And you get a similar trade-off kind of within an assessment, particularly within this context. Because as I've alluded to, if you strip out data or you start manipulating your data, you start suffering on the validity side of things. The most valid data, ethics and legality be damned, is if you just gave it a horribly biased data set and just said maximize prediction of job performance or success. I don't care if it's horribly prejudiced, just maximize prediction of success. That will be your most valid model. However, it will also probably be your most biased. On the flip side, if you said, I want this model to have absolute zero issues with bias, so get rid of anything that shows any shred of bias, great, you're going to have a flawless model from a diversity perspective, but you've probably got rid of almost all of your predictors. And so there becomes this trade-off within the assessment of what is that sweet spot? You want to maximize validity whilst maximizing diversity. And so you want to reduce the trade-off between the two as you're building out your model and you're running that bias mitigation. And that's exactly what this approach does. It kind of doesn't resolve the validity diversity dilemma, but it trumps essentially on both sides of the coin as a more effective approach to bias mitigation. So the approach itself, so we've actually published this methodology as well. It's published in the Journal of Applied Psychology. It's in the top left corner there, but we'll send out the paper afterwards, so you're very free to dive into it in greater detail. We actually also include kind of the secret sauce, so anyone can replicate this approach. Yourselves, our competitors can utilize it. We felt that it was more important that, I guess, the industry as a whole and public perception about bias in AI was, I guess, remedied, than it was to maintain this as a competitive advantage. So anyone can go away and replicate this. And essentially what the graphs on the right-hand side here are showing are kind of that validity diversity trade-off. So on the x-axis, we have your group differences demonstrated by Cohen's d. So the closer we move to the right, as we kind of dial up the strength of bias mitigation with each plot point, you get closer to zero bias. But you're then removing data or de-weighting data in your model, and therefore you're suffering a little bit on the y-axis, which is the human AI kind of agreement. However, in kind of every case, male-female goes a little bit funky because it actually flips to the other side. But you can see that the multi-penalization approach, the thick black line, as you move closer to that zero bias, you're preserving more of that validity on the left-hand side compared to that iterative predictor removal approach. So you can fundamentally end up with a model that is more diverse, less biased, and actually has retained more validity than the other approaches you have of the day. So these approaches, as I said, we've been using them. They've been in circulation on our side for a few years now. So we do have a few customer stories who utilize this effectively. Coda Bank, we work with their contact center, and they're utilizing these approaches in the assessments in the call center hiring. And they had diversity goals. They said to us, hey, we want 50-50 male-female split. I'm sure as AI psychologists, you sometimes slightly feel your hair's gone neck when a customer prospect says we have hiring goals, because hiring goals without actions to achieve them are quite dangerous. But they implement a number of steps, including the assessment tool, and they moved from a 70-30 male-female split to a 50-50 female split in their hiring. Willis Towers Watson, more in the early careers space. Again, we're able to achieve increases to the diversity of their hires. But again, kind of on that validity side of things, we surveyed their stakeholders, gave feedback on how satisfied they were, not only with the candidate diversity, but also the quality of candidates at that final stage in the process, i.e. who are being shortlisted by the AI scored interview, and around 80% of those were satisfied with the quality of candidates that they were seeing coming through that process, whilst they say being a diverse pool of candidates as well. So that pretty much wraps it up from me. I think just I guess in closing, before we go over to some Q&A, I think the key thing that I guess I wanted to get from or apart from this session is that we are seeing increased adoption of AI, of algorithmic approaches, of these big data methodologies in our space and of course in other spaces as well. And we are right, I think, to be cautious and be skeptical, but we've come a long way from those early days, those 5-6 years ago, some of those horror stories where we didn't, or people didn't perhaps know what they're doing, or the techniques weren't sophisticated enough. That we do now have the potential for. I firmly believe we do now have the potential for AI to be less biased than humans. We talk about AI being a black box, but no, the human brain is the ultimate black box. I mean, we as individuals don't know all of our biases, and we absolutely can't turn them off just because we're hiring someone because of a different political affiliation, or you can see a different sports team on their wall. You can't honestly say that didn't affect me in the slightest. But through mitigating AI-based models, in theory, with a sophisticated enough technique and powerful enough tools, you actually could get to a point of zero bias. We're not there yet, but we're working on it. That's everything from me. Thanks for joining, everyone. I can't see there's been any questions in the chat, but I can bring that up now. Otherwise, if you have any questions, please feel free to put them in the chat. Come off mic and shout them out. Otherwise, as I said, we'll send out with a link to the paper as a kind of follow-up after the session today.
Will you share the slides as well, Tom? Do you want the ABP to send them out? Or...
Absolutely, yeah. Slides and the paper. Bit of bedtime reading for you all.
So I think there's you can probably just unmute and speak if you so wish. No need to raise your hand. So if anybody wants to ask a question, just please go ahead.
Hi. Go ahead. Go ahead.
No,
Francisca.
you go first. You go first.
Thank you. Thank you so much, Tom. That was fascinating to hear. One thing I was wondering is, it sounds like you needed a pretty high volume of interviews to train the AI on initially. So it sounds like this is a solution for really high volumes. How low could you go to have the same level of confidence in the solution for client organizations that maybe just didn't have those sorts of volumes for you to do that level of AI training on?
Got you. Yeah, no, good question. So these actually are, I guess you're right, there's a lot of data into the training of these models, but these are now essentially can be deployed as they are. They're essentially pre-built, I guess, models. So we have the 19 competencies. Each has been trained on, probably 7 to 10 different questions. So when we actually then launch or go live with the customer, we don't have to then gather their specific data. We say, okay, you're hiring for grads. You need problem solving, relationship building, and teamwork. We build an interview with a question for each of those and attach the relevant scoring model. And then it doesn't matter if they only have 50 candidates or 50,000 candidates, it then starts scoring them. So yeah, the volume of data to train the models basically now kind of they're packaged and can be deployed to variable volumes.
So they're pre-validated, and I guess that's what that's done is it's created a pre-validated question bank. If an organization didn't want to use questions from the question bank because they had their own, or they just didn't feel it was a good fit for them, what would you do instead?
Yeah, so we can we take the questions we've got and we can tweak or stay close to them. So we'll often get a customer who says like, oh hey, we like this, we don't quite like the wording, can we tweak this a little bit? And it kind of becomes a professional judgment. Like, do we feel it still aligns closely enough to the question set it was trained on? I mean, that's why we have 7 to 10. Is there, there's a bunch of different ways you can ask about problem solving, right? So as long as it's still tapping into the capability, we'll often say, look, actually, this is what you can kind of do. But yeah, sometimes they might say to us, well, actually, we have to assess, like, often they might say, well, we want a motivational question. Why have you applied for this role? Of course, we can't score that off the shelf. So it might be a combination of a few questions are scored by the AI, and a few questions which is a motivation question, and it could be, tell out your experience working with a very specific technology they use. Then the recruiters might use the AI scored interview or the AI scored section to say, right, here's the top 50% of the AI scored section. We review their unscored responses, and that kind of brings some efficiencies through that approach.
Thank you.
Very well.
Francisca?
Yeah. Am I on? Yes.
You are, yes, yeah, we can hear you.
Hiya. Hi. I kind of find it fascinating and at the same time really scary. The power of the analysis, because ultimately it's a fantastic, it's fantastic power under there, power that you're capturing through the process of AI and big data. But at some level, it's also being applied, because it's AI, it's going through an object-focused process, i.e. the individuals are the objects in the process, and yet these individuals aren't like items, like language items, statements, or words. They're actually whole persons in themselves and diverse in themselves. So I think that question around data, number of individuals, and number of as objects is a very different question to the number of individuals as subjects. And then it becomes problematic because you're applying them to subjects, i.e. human. You're applying the whole process and processing to human subjects who also have feelings about that. So I guess I'm kind of thinking, on the one hand, it's true, it's real, it's useful. But on the other hand, it is a form of engineering. Just like social engineering, it doesn't, if ever, it doesn't really work. It works for good and it works for bad. It's sort of, so it's very confusing. And I think this idea of diversity, again, diversity versus what was on the other side?
Validity.
Validity. Yeah. Again, it's also about context. And how deep you can go in the context, or how broad you want to make it. So the question about numbers of individuals and the demographics, it's the demographic, which I guess a demographic is, are they black people or are they white people? That's a demographic that's located within a place. Is a kind of mixing demographics with objects, I think, is, what you're doing. But if you're treating those demographics as collections of subjects who are human beings, interpreting these words, making sense of them, every individual is going to make it different for themselves, the whole experience. So I'm coming from a subjectivity point of view, and what are the implications of human subjectivity in that type of modelling? Because it's still quite abstract. You've got, you've presented it as abstract, and it's not unique to a specific individual or a specific relationship between two individuals in an interview, for example, or who are going to be working together it's just, it boggles my mind, really.
Yeah, no, I understand where you're coming from, and you're right. I mean, it's with these approaches, you are, as much as you can. Of course, our grounding is, practitioners and academics in this space is, our best practices and the techniques have been developed over these decades, right? Some kind of start applying, and as you rightly point out, others just don't. I mean, the certain tests or certain questions that we would expect to be asked if we were delivering a more traditional assessment just don't exist or they don't apply. Because it's just, as you said, it's a totally different way of conceptualizing, I guess, an assessment to that end. So you're right, you have to kind of almost accept that there are some rules that are, I guess, broken or don't exist because they almost can't apply to this. So you have to look at your measures, your ways of assessing, well, actually, is this doing the right thing? And a lot of that still applies, right? As I said, of course, you still go through the same process with any test and evaluating its utility and its effectiveness and all this with the real world data when you're applying it. And that's almost what you have to use as that source of truth and saying, well, is it getting us the best candidate or good candidates? And are they diverse hires at the same time? Even if the process of getting that is different to perhaps the other measures that a company might be using in the same process. The first step may have been a traditional personality questionnaire, and then you have an AI score interview. But I guess you're right, they're kind of almost more evaluated by the outputs or appraised by the outputs at the end of that. But yeah, certainly never expecting it to be overly clear and straightforward. It's and it's an evolving space as well. So this talk, if I gave this 18 months ago, was 18 months before then, it would have been look quite different. So yeah.
Yeah, I must say I was struck by your statement. It's early days, and then you said 5 years.
I mean, it is in the grand scheme of it. Certainly, it's early days. I think.
Years. That is early days, isn't it? If it's only 5, if you think about the kind of context that everything's ahead, isn't it? It's not because it's kind of so new, and it's like the paradigm is just completely, the shift has been made.
Correct. And look, and that's the thing, right? Then we're the first company to do the AI scored interview. So we did the first versions around 8 years ago. That's when we first started applying it. When before, kind of these large language models were sort of big on the, were already out there. And yes, only kind of really in the last 12 months or so, of course, we're now seeing full regulation and external, I guess, kind of benchmarks or external standards put into place. Up until now, companies such as ourselves, or there is Amazon or ABP, basically policing themselves. And it's made it quite interesting. As I've been at Heidi for 6 years now, and it's been quite interesting because I started at a more traditional assessment vendor, kind of almost having to say, these are the questions you should be asking me, and I'll give you the answers. And of course, that's very dangerous because, of course, you're only going to tell them to ask the questions you've answers for. Whereas when it's a more traditional method, people might have like a checklist, like, right, ask them to see this, ask to see that, ask to show that, and then you kind of know. So yeah, you're kind of almost worse of, I guess, having to educate people whilst then sort of, my team would be selling to them, which is a slightly strange situation to be in. So it's very good that the regulation is catching up, but you're right, in the grand scheme of things, this is still, I think, very early days. 5 years from now, it'll be a totally different beast.
Exciting, though.
Certainly is.
Thank you.
You're welcome. I think I saw another one in the chat. Plans to adapt this technology to score other methods, be it SJTs, whatever, or only be useful for scoring interviews. And I guess the technique, I guess it depends on the question there. I guess for the bias mitigation technique, that really can apply to, I'm going to say truly anything. But as I think I used the example earlier of something like those something like mortgage applications or whatever it may be. In theory, you could apply it to many or any of those situations. It's not explicitly for natural language based approaches. It can be applied to anywhere where there's large volumes of data, large number of predictors, and you're looking to mitigate the bias. I guess the question is more on specifically, I guess, the interview technology. Yeah, in principle, anywhere where there is natural language, so you could in theory apply it to like written text. So whether that's a cover letter or a CV or social media profiles, you certainly could. We've chosen not to. We don't want to apply it to those areas for various different reasons. Though, as it currently stands, it's been purpose built for verbalized interviews, and so it takes a lot of reworking or some reworking to change it to a written format. But yeah, we're keeping it there for now. And what's next for Harvey after this? So we are, well, we recently, about 12 months ago, we acquired Modern Hire, so a large competitor of ours in the States who had a lot of more traditional type assessments, the virtual job tryout. So for assessment standpoint, we brought that to try to, or to expand our different assessment portfolio. Because to the point earlier, some companies or even people within companies might say, hey, I've got interviews, sounds great. Others would say, this terrifies me, I don't want any of my candidates. So being able to actually have different offerings for different levels of AI adoption, I think is really important for us. More broadly, though, we are starting to look more at kind of that kind of job matching capabilities. So we sit on a lot of data. We have about 1,200 customers around the world, and I forget how many. I want to say probably in the region of 45 to 50 million interviews being completed on the platform. And so that question earlier, then actually looking at, well, what jobs did people get hired into, and then were they actually ultimately hired, or were they even successful? We're starting to try to understand how actually can we map some of that, so that from a candidate's sort of response to particular questions, could you actually start to understand, well, this person isn't a good fit for this particular role they applied for, but actually it would be a good fit for these different roles within your organization that you aren't currently hiring for based on certain behavioral indicators or whatever they may be. So that's what we're looking to move a little bit more towards, less of this kind of repetitive process where you're applying, you apply for a job, you go for a process, you either succeed or you don't succeed, and if you don't succeed, the slate's wiped clean. Start again, either the same company or a different company. And there are companies out there that have been trying to do this or have looked at that kind of matching approach. And yeah, we're starting to explore that as well from an innovation standpoint, because we sit on this data, we sit on this technology that is very powerful at processing and finding patterns in data. We're trying to understand if we can apply it to that sort of context. Good questions though. Any more questions for anyone in the chat or off on mute?
Any more for any more? So what do you think, Tom? Should we draw it to a close? Is there anything you want to say by final parting words? Yeah.
No, happy to wrap things up there. Yeah, thanks. Thanks again for joining. And I said we'll shoot those slides out to you, and yeah, we'll link to that, to link to the paper as well, so you can dig into that a little deeper if you are so inclined. But
thanks for your ABP award-winning insights as well, because this piece of work quite rightly won you an award. So thank you. If anybody wants to pop on the 27th of November, that's when we'll be reviewing this year's award. So I think we'll say it's a wrap, shall we? If everybody wants to put their camera on to say a nice goodbye, and we can do that. Thank you, Lisa. Yeah. Thank you, Rainer. Peter. Yep.
Perfect. Thanks, everyone. Have a good evening. Go for and enjoy your dinner.
Thank you. Bye-bye.
Bye.
Bye.